ionic equilibrium. So before start this chapter, let's discuss about our conductors. Those substances which conduct electricities are called conductors. And for insulators, the substances which do not conduct electricity that are called insulator. So here we are basically discussing about of the conductors. So conductors, they are conducting electricities due to maybe presence of free electrons or maybe presence of free ions. So conductors can be classified into two types, that is metallic conductors, another is ionic conductors. So metallic conductors, this is the metallic conductors. Another is ionic conductors. So metallic conductors, this is so conductivity due to movement of free electrons, and ionic conductors conduct electricity or show conductivity due to movement of free ions. So basically in this chapter we are discussing about of these free ions. So if I says that these solutions, in these solutions, let's say Ag plus and NO3 minus ions are there, and we have the electrodes. This is cathode. Cathode is positive charge. This is anode. Anode electrode, that is negative charge. So this is so we give the electricity. Then when you give the electricity, then what happened? The ions moves towards opposite. Ions moves towards opposite electrodes. So here for Ag ions, Ag plus cations, so it will move towards the opposite electrodes. So here opposite electrodes is this anode, so this moves towards anode. And for NO3, this is minus, so it will move toward opposite electrodes. So for this it will move cathodes. So due to this movement of ions present in the solutions, they are able to, so due to this movement they are able to complete the circuit and electricity will flow. So how many this free ions is present? So if more number of free ions is present, then it able to conduct electricity more easily and more fast. So it depends on how many ions are present in the solutions. So that if more number of ions is present, then it will able to conduct electricity more. So next we will discuss about the type of ions. So this can be a strong, so based on strength. So this can be strong electrolytes, ions I am saying as electrolytes. Another can be weak electrolytes. So strong electrolytes are those which completely ionized, and weak electrolytes are those partially ionized. And here we have studied that we already studied chemical equilibrium for strong for strong electrolyte alpha is equal to 1, approximately equal to 1. So alpha means we studied the number of moles dissociated 4 moles. So here suppose HCl is there, then it's dissociated into H plus Cl minus. So T equal to 0, suppose 1 mole is there, so nothing has dissociate, and T equal to T at time T, this is fully ionized, means 1 molar, which 1 molar of solution molecule was there, that is completely gives ionized. So 1 mole of H plus and 1 mole of Cl we get. So no HCl molecule is present at time T, so it is completely ionized into ions H plus and Cl minus. So at T equal to T, we are getting only the ions, not the molecules. So this is completely ionized. For this case, alpha equal to 1, approximately equal to 1. Whereas for weak electrolytes, alpha is less than 1, and that is you can say very less, like 0.5%, 0.5 or 5%. That is 0.05. So this amount of less value alpha for weak electrolytes. Let us say CH3COH is weak electrolytes. So what it will do, it will partially ionize CH3CO minus plus H plus. Then what T equal to 0, T equal to 0, suppose this one molecule is present and no molecule has produced, and T equal to T, this from 1 mole only alpha has ionized. So alpha of CH3O minus, alpha of H plus. So this alpha is very less, that is 0.05%. So from 0.05% it get ionized, means still 95% of CH3 is present in the solutions. Only 5% ions of CH3O and 5% of H plus is present in the solution. So in the solutions, if you see, still CH3COH molecules is there, and very less amounts of ions are present, CH3CO or H plus. So for weak electrolytes, so you will get very less number of ions in the solution, so it will produce less electricity. So electrolytes can be classified as strong electrolytes and weak electrolytes. So if I say strong electrolytes and weak electrolytes, so strong electrolytes for strong acids. What are the strong acids? That is HCl, H2SO4, HNO3, HBr, HI. These are the strong acids. Where for strong base, if you say weak acids, we can say for weak electrolytes, suppose weak acids, then what organic acids like COH, HCOH, and if I say H3PO3, H3PO2, boric acids, that is H3BO3, all these are weak acids. And for strong base, if I say, so strong base are like we say KOH, NOOH, and we can say BaOH2, CHOH2, ASOH2. These all are like second period elements, second group atoms, except we can say lithium. If you accept lithium, so all oxides or hydroxides of first and second groups that are considered as strong base. So similarly for weak base, weak bases are like you say NH4OH, CaOH2, ZnOH2, FeOH3, these things. And for salt, this side was tested strong, these are weak electrolytes. For strong electrolytes, if I say salts, in salts we can get for strong electrolyte, for salt, that any one component, salt we are getting one component as base, one component as acid. So for salt, any one component, if it belongs from strong, then that salt is considered as strong salt. So if I say examples like NaCl, KCl, NH4Cl, so these are considered strong salts. And for weak salts, like any components belongs from so for weak electrolytes, both the components should be from weak electrolytes, from weak base or weak acids. Like if we say NH4CN, this NH4 is belongs from NH4, that should belongs from NH4OH, NH4OH, and this is belongs from HCN. So HCN is weak acid, and NH4OH, this is also weak acid. This is from weak base, this is from weak acid. So this is weak electrolytes, means both the components has to be from weak base or weak acids. Like if we say NH4 to CO3, so this is belongs from NH4OH, weak acid, and this is belongs from H2CO3. This is from weak base, sorry, weak base. This is also from weak acid. So both the components should be belongs from weak acid or weak base. Then that is known as that is considered as weak salt. And for strong salts, both any one components either from acids or from base should be from strong. Like if both belongs from strong, then also it's fine, but at least one component should belong from strong acid or strong base, then that salt is known as strong salt. For weak salts, both the components should belong from weak acids and weak base, then that is considered as weak salt. So next we are going to study the theories of acid base. So in earlier mainly three theories we are going to consider. All the many theories were there, but three theories are very famous. So first theory is Arrhenius theory. What he says, so this theory is mainly aqueous solvent theory. You can say this is aqueous solvent theory, means the solvent has to be aqueous. So according to him, that Arrhenius acids, that are those electrolytes which which produce or donate H plus or H3 plus ions in aqueous solutions are called arenous acid So what he says ki any solutions, any electrolytes which produce or which donates H plus or H3 plus ions in aqueous solutions are called arenous acid. So according to him, suppose this HCl in aqueous medium, this gives H plus Cl minus. So since in aqueous medium H plus is given, then this is arenous acid. Similarly, if we say H2SO4 in aqueous medium, this gives what? 2H plus SO4 minus. So in aqueous medium, this is giving H plus. The positive ions is H plus. So this is known as arenous acid. Now example, if I say HCl in gas, give H plus Cl minus. When this is arenous acid, answer is wrong. So what it says, arenous is for arenous acid that should be in the aqueous medium. Since this is a gas, so it's not. So this is not arenous acid. So not a arenous acid. Although it is giving H plus, but still it is not arenous acid, because for arenous acid that should be in the aqueous medium or aqueous solution. So here we are taking as the gas, or in gas also it is giving H plus and Cl minus, but still we are not take HCl as arenous acid, because arenous says that for a acids that has to be in the aqueous solution, and in the aqueous solutions positively charge should be only H plus, then only that is considered as arenous acid. So here, since aqueous solution is not there, although it is giving H plus ions, H plus positive ions, but still it is not considered arenous acid because here aqueous solution is not there. Similarly, another example, if I say NaHCO3, what will give? Na plus H plus CO3 minus. This is in aqueous solution. Then, is it arenous acid? Still it is not a arenous acid. What he says, aqueous solutions, and the ions should be, the ions, that is positively ions, should be only H plus. Positively ions other than H plus, if other positive ions are present, then that is not considered as arenous acid. So NaOH3 is not arenous acid, not a arenous acid. Although here H plus ions is present and aqueous solutions is aqueous solutions, but still not arenous acid. Reason, because he also says that the ions, the positive ions should be only H plus. If other than H plus, other ions is present in the solutions, other positive ions is present in the solution, then that is not considered as arenous acid. So NaCO3 is not a arenous acid. Whereas HCl, only H plus aqueous solution, so HCl is arenous acid. H2SO4, in aqueous solution 2H plus is giving, so only H plus is there in aqueous solution, so this is arenous acid. So for arenous acid, two conditions it has to satisfy. First, it should be in aqueous solution. Secondly, should have it should have positively charged ions as H plus or H3O plus only. Why H plus is small charge, so H itself is a very small size, and when H plus is coming, it become very small size. So in here water is there, so water is a lone pair. So what happened, this lone pair donates to H plus to stabilize H plus, and it become H3O plus. So this is actually H plus, but H plus is not existing practically. So when they practically look, then H plus they are not getting, they actually H3 plus is there. Reason is H plus, H itself is a very small size, and itself is a small size, and with that positive charge is present on it, so it become very small size. So water is present around H plus, so this actually in existing H3O plus, because lone pair of oxygens donates to H plus, and they actually exist in as a H3O plus. So it should have positively charged ions as H plus or H3O plus only. If these two conditions satisfied, then that is known as arenous acid. Other than that is, otherwise that is not arenous acid. It may be salt or it may not be acids. So next, for arenous base, what is it? Those electrolytes which donate or release OH minus ions only in aqueous solutions are called arenous base. Example, if I say H, then NaOH in aqueous solution, this gives Na plus OH minus. Then if I say KOH in aqueous, then it gives K plus OH minus. And if I say CH3 NH4OH, aqueous, it gives NH4 plus OH minus. So these are arenous base. Now the example is, suppose if I say aqueous, it will give Cu2 plus OH minus plus Cl minus. Is this arenous base? Arenous base? Answer is no. Why? Because for arenous base, the negatively charged ions should be only OH minus. If other than OH minus or with OH minus, if other ions present, then that is not considered as arenous base. So here, although OH minus ion is present, but with it Cl minus ion also present. So for arenous base, only OH minus ion should present. Negatively charged ions is only OH minus. No other negatively charged ions should present for arenous base, and that should be in the aqueous medium. Then these two conditions if satisfied, then all that is known as arenous base. So here, the other than OH minus but negative charge ions, Cl minus negative charge ions is coming. So this is not a arenous base. So let's discuss some in these chapters. When we progress these chapters, we are going to study that degree of dissociations. So it's good to study type of acids. Types of acids. So this can be, one is monobasic acids, another can be diabasic acids, another is triabasic acid. Monobasic acid means gives 1 H plus per molecule. Diabasic means gives 2 H plus per molecule. Triabasic means what gives 3 H plus per molecules. So this you can say example, that is HA means 1 H is there, here H2A, here H3A. So this type only 1 H is present, 2 H is present, so this has to able to give 2 H plus, 3 H plus. Here example you can say HCl, then we can say CH3COH, these all give 1 H, and we can say CH3COH, and we can say let's this, then this comes, for this class comes like H2SO4, and for this class we can get H3PO, for this class we can get H3PO3. So you can say HCl, H3, CH3COH, and we can say also a lot of examples are there which gives 1 H plus, like what I said, examples like HBr, HI. So all this gives 1 H plus. So why this type of study is important to remember the which is monoacid, which is diabasic, which is triabasic, because when you say that for this acid, monobasic acid, when it will be ionized, it gives H plus plus A minus. So when we study that, then how much it dissociate? 1. Suppose T equal to 0, this is 1, this is 0, 0, and T equal to T, this will 0, or we can say weak acid, then 1 minus alpha, this is alpha, this is alpha. And if H is a diabasic, then what happens? This will 2H will be there, so it will give 2H plus. So for that, this will be alpha, but this will become a 2 alpha. For if it is triabasic, then this is 3, then this will be alpha, but this will be how much? H plus it will give 3, so it will become 3 alpha. So similarly for basic also, so we should know that which is diabasic. So for monobasic, that is 1 alpha 1 alpha, it's fine, but if diabasic or tribasic, then according to that number of moles it will dissociate. So that's the reasons this you have to know idea about which is monobasic, which is diabasic, which is tribasic. That will helps you when you are doing the calculations. So we will discuss these things also when you are solving problems, but it's become important to say before that, so that we can remember that which is monobasic, which is diabasic, which is tribasic. We should have some idea. So similarly for types of bases also, we have monoacidic bases, diabatic acid, so diacidic base, we are having triacidic base. So this means gives 1 OH minus 4 molecule. This gives 2H minus 4 molecule. This will give 3OH minus 4 molecule. So 1 OH molecule, that like NOH, KOH, these are all giving 1 OH minus. And if we say dibasic, then like MgOH2, BaOH2, all this give 2H minus, and this is like FeOH3, AlOH3. So this gives tribasic. So similarly, like that, we can do that if, or I can take here. So similarly basis, if like M OH there, then how much that is dissociating, M plus OH minus. So if monobasic, then alpha. If it is dibasic, the 2H minus will giving, then it will become 2 alpha. If it is tribasic, then it should be 3, then it is 3 alpha. So these things will be help you when you are doing calculations. So according to that, if monobasic, diabasic, tribasic, if monobasic, then that is giving 1 alpha. If diabasic, 2 alpha, tribasic means 3 alpha. So that will help you when during the calculation. So we have some idea about of this monobasic, which are diabasic, which are tribasics. So arenous acids we are studying. So what are the limitations of arenous acid? Limitations is that it only talked about aqueous medium, so not able to explain acid or base in gaseous medium. These are the limitations of arenous acids. So the second theory is come, that is Bronsted-Lowry concepts, or this is also called conjugate acid-base concepts, or also they are saying that are protonic concepts. So what this theory actually says, that acids, if you say one is acid, then that has to be, okay, I will stop this.